Good morning. Today we're going to talk about some of the segments in a circle. So the first one is if we have two chords. Remember, a chord is if you have a segment that goes from side to side of a circle. It can go through the middle. If it goes through the middle, it's a diameter. Otherwise, it's just a basic chord. And if to find the length of a chord, you multiply down the chord. So in this case, A times B will equal C times D. So you multiply the two pieces of the chord together and set it equal to the other side. Okay, there's an example if you want to look through it. Let's do a couple examples together. So we're going to do our segments of our chords. So 3 times 6 equals our other side. So 2 times x. 3 times 6 is 18 equals 2x. And then it's a very basic equation. Divide by 2 and x equals 9. Okay. Same idea here. So no matter what, you're just going to multiply the two sections of the chord together. X times x equals 2 times 10. Okay, so x times x equals 2 times 10. Remember, x times x is x squared. 2 times 10 is 20. In order to solve for a square root, or a square, we take the square root of both sides. X equals square root of 20. Square root of 20 is not a perfect number. You have a couple options depending on what it asked you for. You can either plug that in your calculator and find the approximate value, which is approximately 4 point, let's see, off the top of my head, I can't think. 4.47. Or, remember we simplified radicals before, where you break them up into factor tree. 4 times 5, 4 is 2 times 2. You can have a group of 2's goes outside and a 5 left over. So 2 square root of 5. Okay. It does say round each answer to the nearest tenth, so it actually would put 4.5. Okay. Remember, those are options you might see. All right. Here again, we have 6 times x equals 8 times 8. So 6 times x equals 8 times 8. 8 times 8 is 64. In order to solve for x, divide by 6. Okay, so x equals, and then we'll plug in our calculator, 64 divided by 6, which is 10.7, rounded to the nearest tenth. Okay, it does not matter which chord you set first. We could have done 8 times 8 equals 6x. Either way, just pick one of the chords and multiply the pieces together. Okay, x times x plus 7 equals 3 times 6. So x times x plus 7 equals 3 times 6. Of course, we're going to have to distribute this because there's set of parentheses. X times x is x squared. 7 times x is 7x equals 18. With quadratics, remember this quadratic because it has x squared, we're going to set it equal to 0. And then we can factor. Negative 18 goes up top, positive 7 on the bottom. Two numbers that multiply to give me negative 18 but add to give me 7 are positive 9, negative 2. All right. Once we have our factors, remember we set each factor equal to 0. So x equals negative 9, x equals 2. If I were to plug in negative 9 here, this would mean that this section is negative 9 long. It doesn't make sense for it to be negative 9 because you can't have a negative 9 distance. So the answer that works is 2. All right, 5. So notice 5 does not give me a whole lot of information. It just tells me that this section is 5. But notice that they intersect at the middle, which means that both of those sections will both be 5 because they are radii. All right, on the other side, I have x plus 2. Again, it's meeting in the middle, which means that this one will also be x plus 2. So I have 5 times 5 equals x plus 2 times x plus 2. 5 times 5 is 25. We're going to distribute x squared, 2x, 2x, and 4. Okay, I'm going to set it equal to 0, so I'm going to subtract 25 and combine my like terms at the same time. 0 equals x squared plus 4x minus 21, and we're going to factor. Negative 21 up top, positive 4 on the bottom. Two numbers to multiply give me negative 21, but add to give me 7. Or multiply give me negative 21, but add to give me positive 4. All right, positive 7 and negative 3. Okay, set each factor equal to 0. And x equals negative 7, x equals 3. Again, if I plug in negative 7 here, negative 7 plus 2 is negative 5. That does not make sense, so my answer has to be 3. Okay, so all of these are going to set up the same way. So these one, notice it's x, split it in half because of the rules we talked about before with chords. So this section will also be x, and you would just plug it in the same way. X times x equals 2 times 7. Okay, so the rest of these are more or less the same. Remember, we got it, if we have quadratics, we have to set it equal to 0 and factor. If you can get just an x squared, then no x term, then you can do what we did in number 2. Okay, backside. So these are talking about secants and tangents. Remember, secants kind of are like chords that keep going. Tangents just intersect one time. The rule for these ones, just to make it a basic rule, is outside times whole. If you can remember outside times whole, that will work for both the secants and the secant and tangent. All right. Here's an example for you if you want to look through it. These are tight in here. So let's try to do this whole problem. All right. So we're going to do outside of this piece. So what piece is outside? It's 3.3 times the whole thing here. Just so happens that the whole thing is the same thing as the outside piece equals the outside piece of the second one. So 2.2 times the whole thing. So in order to find the whole length, we're going to add together x plus 2.2. And we're going to distribute because we have parentheses and multiply. So we're going to multiply 3.3 times 3.3, which is 10.89. I am not going to round until the end. Okay, 2.2x plus multiply 2.2 times 2.2 is 4.84. Okay, subtract 4.84 from both sides. 6.05. And I'm going to do 6.05 divided by 2.2. I'm running out of room, which is 2.8. Number 2, same idea. So outside is 16 times the whole thing. So 16 plus 26, which is 42, equals the outside, so the part that's not inside the circle, 18 times the whole thing. So we're going to add them together, and we have 18 plus x. Okay, multiply together. 16 times 42 is 672 equals 18 times 18 is 324 plus 18x. Subtract 324 from both sides. 348. And then I'm going to divide both sides by 18. And x equals 19.3. Okay, so same idea with all of these. So we're just going to do outside times whole. So they're marked the same. So this is 8. This is 8. Outside is 8. Whole thing is 8 plus 8, which is 16, equals outside, which is 6, times the whole thing. We're adding them together. 2x plus 6. All right, I'm going to multiply 8 times 16. It's 128. Distribute. 6 times 2x is 12x. 6 times 6 is 36. Subtract 36 from both sides. 92 equals 12x. Divide both sides by 12. And we get that x equals 7.7. All right, let's look at number 8. So notice that this section is a radius. So this section also would be a radius. So it's 15. Okay. So we have a whole bunch of extra stuff. This part over here I don't really need. Let's just think about it the way we've been doing it. Here's one section and here's my other. So on this one, my outside and my whole are the same thing. So x times x equals my outside portion, I'm trying to use a different color, is 5 times the length of the whole thing. So 5 plus 15 plus 15, which gives me 35. So x squared equals 5 times 35, which is 175. We can take the square root of both sides. And x equals 13.2. Same idea with number 9. Notice that this is a radius here at 6, which means this is a radius here. It is also 6. I don't need this section. That's just kind of extra information. We would set it up the same way. So outside times whole equals outside times whole. I add it together. X plus 6 is x plus 12. And we would distribute the same way we've been doing and solve. All right. Let me know if you have any questions.